Hi everyone, today we're doing lesson 7.5. We're going to divide powers that have the same base. If you know the multiplication rules, the division rules are not much different. You'll see in a second. Okay, so let's talk about dividing powers with the same base. Let's look, I have 2 to the 6th power over 2 to the 2nd power. That's the same as 2 times 2 times 2 times 2 times 2 times 2. I think I got the right number there. Over 2 times 2. Well, I don't know if you remember this, but we can cancel out this 2 and this 2 because 2 divided by 2 is 1. And cancel out this 2 with this 2, again, because 2 divided by 2 is 1. So I'm just left with 1 on bottom. And 2 to the 4th power. 2 to the 4th power over 1 would just be 2 to the 4th power. Let's look at the next part. So x to the 7th power divided by x to the 5th power would be the same as x times x times x times x times x times x times x over x times x times x times x times x. Okay, again, we can cancel out some of these x's because x divided by x is 1. And as you can see, I'm just left with 2 x's on top, or x to the 2nd power. Okay, now let's look at this. Do you think you can make a rule? I have 2 to the 6th power divided by 2 to the 2nd power, and I ended up with 2 to the 4th power. Here I have x to the 7th power and x to the 5th power, and I ended up with x to the 2nd power. Well, hopefully you noticed that when I divided these, all I have to do is subtract the exponents, as long as they have the same base. So 6 minus 2 is 4. 7 minus 5 is 2. Now let's talk about quotients to a power. Here I have 1/2 to the 4th power. Well, what does that mean? Well, that means 1/2 times 1/2 times 1/2 times 1/2, which is the same as 1 to the 4th power over 2 to the 4th power. I could simplify that further and make it 1 over 16. Just like over here, I could have made this into 16, and I probably should have, but I wanted you to see the 2 to the 4th power. Okay, how about x to the 2nd power raised to the 3rd power? Well, that's the same as x to the 2nd power times over y, I forgot the y, times x to the 2nd power over y times x to the 2nd power over y, which leaves me with x to the 6th power over y to the 3rd power. Well, hopefully you notice that this, when you have a quotient to a power, you have to take both the numerator and the denominator to the 4th power. In this case, we have the power to a power, so I'd multiply these powers, x to the 6th power. My y here is just to the 1st power, so that would now be to the 3rd power. So to raise a quotient to a power, I have to raise both the numerator and the denominator to that power. And then, as always, simplify if you can. I forgot to clear, so I'm going to go back and make sure I do that. Okay, so I have a couple examples here for you. First of all, I can simplify this fraction. What is 12 over 15? Always look at your numbers first. 12 over 15, I can divide them both by 3, and this would become a 4, and this would become a 5. It's still negative because it's negative. 4 over 5. Now let's look at my c's. As I said, I subtract. C to the 12th minus C to the 9th gives me C to the 3rd power. And that's done. Let's look at my next example. First of all, I want to look at my numbers. I have 49 and 21. I know that 7 goes into both of those. 49 divided by 7 is 7. 21 divided by 7 is 3. So I'm going to have 7. I'm making a long line just in case I have a lot of stuff. Over 3. Well, now I have a to the 4th on top, a to 6. 4 minus 6 will give me a to the negative 2. I'm going to write them all on top to start with so I can figure out which ones need to go downstairs. Now I have 7 minus negative 2. Think about that. 7 minus negative 2. Remember, minus negative becomes a plus. So my b will be b to the 9th power. Now here I have negative 3, c to the negative 3, minus negative 5. Again, that becomes a plus, which will leave me with c to the 2nd power. I have some cleaning up to do because I have this negative exponent on top. I'm going to move it downstairs. That will leave me with 7 b to the 9th power, c to the, that's a bad 9, c to the 2nd power on top, and 3 a to the 2nd power on bottom. Okay, let's look at my next example. This time I have a quotient to a power, which means I have to raise everything, both my numerator and my denominator, to the 3rd power. Well, w to the 5th power raised to the 3rd power, power to a power, I'm going to multiply those powers. So I'm going to have w to the 15th power. Then I have to raise my 4 also to the 3rd power on bottom. I can simplify that 4 to the 3rd power. 4 times 4 times 4 is 64. And I still have w to the 15th power on top. Let's look at this next example. I'm going to write this whole thing out before I move things around because I think that just makes it cleaner. I have to raise my 3 to the negative 4 power and my c to the 3rd to the negative 4 power. It's going to leave me 3 to the negative 4. And my power to a power, my c to the 3rd raised to the negative 4 power will be c to the negative 12. In the denominator, I have to raise this d to the 2nd power to the negative 4 power. 2 times negative 4 will give me d to the negative 8. Now I have all sorts of negatives. My d to the negative 8 is going to have to move upstairs, whereas both of these, my 3 and my c bases, will have to move downstairs. That will leave me with d to the 8th power in the numerator once that's moved upstairs. And in the denominator, I will have 3 to the 4th power and c to the 12th power. My last step, I can evaluate 3 to the 4th power, that is 81. c to the 12th power in the denominator. And in the numerator, I will still have my d to the 8th power. Okay, I got a lot going on here. What I recommend is you simplify an expression before you apply this exponent rule. So let's do what's in the parentheses first. I have y to the 3rd over y to the 10th. So 3 minus 10 will give me y to the negative 7 power. And that's going to be raised to the 2nd power. Now I could move it downstairs, but I might just wait a little bit before I do that. Let me raise my power to a power first. That will give me y to the negative 14. Now that I have that, I know I don't have any other work to do other than moving things downstairs. So now I'm going to take that negative 14, move it downstairs. I'm going to have y, 1 over y to the 14th power. Could I have moved that downstairs earlier? Yeah, I could have had 1 over y to the 7th and then raise that to 2nd power. But I did that for a reason, which we might see here. Let's start with my fraction. My fraction is going to be 2 over 3 once I simplify it. I have x to the 2nd over 4. X to the 4th, 2 minus 4 is x to the negative 2. My y to the 6th divided by y to the 3rd will leave me with y to the 3rd on top. And all of this is being raised to the negative 3 power. Now, like I said, I could have moved this downstairs first, but I'm multiplying all of these, raising my power to a power by a negative exponent. So it would just involve me moving things twice. So I'm not going to do that. First, I have 2 to the negative 3 power because I have to raise everything in the parentheses to the negative 3 power. X to the negative 2 raised to the negative 3 power to a power. I'm going to multiply those. That will give me x to the 6th power. Now I have y to the 3rd raised to the negative 3rd power. So 3 times negative 3 will give me y to the negative 9. And in the denominator, my 3 I have to raise to the negative 3 power. Okay, now I have to move things around. My 3 to the negative 3 is going to be going upstairs. My y to the negative 9 is going to be going downstairs. And my 2 to the negative 3rd power is also moving downstairs. That will leave me with 3 to the 3rd power in the numerator, along with x to the 6th power. In the denominator, I will have my 2 to the 3rd power and my y to the 9th power. My last step, I can evaluate 3 to the 3rd power, make that 27. 3 times 3 times 3. And in my denominator, I will have 8, 2 times 2 times 2, times y to the 9th power. Now I am done. Okay, I have a rectangle that has an area of 72, a to the 3rd, b to the 4th, and I want to know the length of this side. I know this side is 6a to the b. Well, I know area equals length times width. In this case, I know my width, but I don't know my length. So I can take my area divided by my width to give me my length. So let's fill those in. I know my area is 72 a to the third, b to the fourth. And my width is 6ab. And when I divide these, I will get my length. I'm going to write it in cursive so I don't think it's a 1. Okay, let's simplify my numbers first. I can divide these both by 6, and I'll end up with 12. When I divide, I subtract, remember. So a to the third over a, this is to the first. 3 minus 1 will give me a to the second. A b to the fourth in my numerator, b to the first and bottom. 4 minus 1 is 3, so b to the third power. So 12, a to the second power, b to the third. There would be a 1 on bottom, but since you're dividing by 1, you don't need to. So which one looks like this? I have a denominator in all of these except for these two. I have a to the second power, b to the third power. It looks like b is my correct answer. So just a quick summary. When I'm dividing powers that have the same base, I subtract my exponents. When I'm raising a quotient to a power, I have to remember to raise both the numerator and the denominator to that power. Then you always simplify. Well, that's it. Have a great day. I'll talk to you soon.